Hello, my name is Steve Quern. I'm the creator of the Shell Project Spacecraft Design concept. And I deleted the PRISMA3D from my tablet. And then I decided to restore it. I was worked on a non-Spacecraft project. And I learned some things that that are not noticed before. One of the issues I had, you couldn't change the name text because it's not down here. You have to change it right here. Material coding. Okay. How do you cannot change the text on that? So that's an issue. Okay. Font is the last thing you want to change. I mean, the scale is the last thing you want to change based on my previous experiences before this update. So, project name, texts. Multi-Motor Engine Spacecraft. Okay. And then we're going to scale that. So, now there seems, I believe that these values are now stick. That may or may not be true. I'll move it. Minus 110. Scale 1 text. Fonts. Just the regular. Scale 1 equals 1 foot. 0 inch. Now the font, oops, nope. Okay, the font, there is apparently one, there is a max amount of space with version 3. There's a max amount of space you can put on the text line. In version 2, there's basically none. Well, there was, but it was very, very large. And the font that you use, the font style that you use, will shrink, will alternate how many characters you can have on that line. For example, if I use the bold mode font, I may not be able to do this entire thing on one line. The inch or inches will be knocked off a little bit. So okay, so you can't reposition these. Okay, so version 2 of changing position of the is not happening. Yeah, let's get out of this. Oh, what did I name it? Multi-Motor Engine Spacecraft. Okay. Rename it. Okay. There we go. Let's exit that. Okay. I'm just playing with the positioning. Let's see what's going on here. Okay. Instead of going with the Yamato hull, I can do the Flower Child Project series design. Okay, so let's go with the cylinder. We're going to rename the cylinder the command module. Let's see here. The Flower Child Project series. The Flower Child series spacecraft design is basically a static model. It's a revision. It's a way of the series is designed for revising the Apollo CSM-LM spacecraft design. How does the Flower Child series differ from the Apollo? How does the Flower Child series or the Lunar Child series differs from the Apollo CSM-LM spacecraft design? And yeah, that's what the Flower Child series does. That's the primary role of the Flower Child series. It's to test out science and technology and proof of concepts. So the command module, the Apollo command module, is 13 feet in diameter. The external measurement is 13 feet in diameter. I was wondering, I'm trying to get rid of that. Okay. Now, between 1992 and 1993, I was a member of the Planters. I had one-year membership of the Planetary Society. And at that time, the Planetary Society was bitching and complaining about the University of Nebraska electing the Apollo capsule 009, which was in its position for care and maintenance and displaying. So the Planetary Society created a petition and wanted us the membership to sign the petition to send to the University of Nebraska. I didn't sign that petition, but I used the opportunity to contact University of Nebraska about the Apollo capsule and see what information it can give me on the Apollo CSM LM. And because back in 1985 when I conceived the project, the Flower Child Project, back then it wasn't called the Flower Child Project. And at this time I was a membership before I got NASA, it was not known as the Flower Child Project. It was only after I got the information from NASA that my spacecraft project is called the Flower Child Project. But back in 1985, the concept has always been, how do we convert the Apollo CSM LM into a modern day Earth-to-Moon spacecraft, orbit-to-orbit only spacecraft that can do 1 month missions, 3-month lunar missions, and as an orbit-to-orbit only spacecraft design. And so I needed information on what the actual numbers of the Apollo CSM LM. And back in 1985 and 1986, when I said, yeah, this, between 1985 and 1986, I was arguing about, is this a good thing to pursue? And by 1986, I said yes. But I had no information, so the Flower Child Project was on hold. And it's been on hold until 1992, 1993, when I became a member of the Planetary Society. And I contacted the University of Nebraska about the Apollo 9009 capsule. And I ended the letter with, oh, by the way, if you're not maintaining the spacecraft capsule, so that's bad, you know, you're in the wrong here, type comment. That's not right. I forget exactly what I said there, but it was basically, I am a member of the Planetary Society, but I did not join the thing. But I do agree with the Planetary Society saying about the Capsule 009. So, based on the information they gave me on Capsule 009, it is 13 feet in diameter. The maximum diameter is 13 feet. And the height of the capsule was 9 feet. Come on. Okay. And the top of the capsule was 2 feet. And they changed that, so let's see here. So what I'm going to do, let's move this out of the way. Let's create a new model, sphere, scale it. 2 feet, 2 feet. I'm going to make it 3 feet. I'm going to change it to 3 feet. That way you have 6 inches of framing and 6 times of framing. And then that leaves you 24 inches for astronauts to get in and out and stuff for the spacesuit. Okay, and then, okay, we need to scale that. 9.1. We gotta move it. That. Scale it. Okay. Undo that. Okay. Undo that. Undo that. That's good as it's going to get. So I'm going to delete it. Delete. Command module. Oops. Model that. Delete. 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 I said delete. Delete. delete that. Okay, now command module, scale it. Okay, values don't stick, but we're just going to double that. So that is basically what the Apollo CSM, the Apollo command module looks like. Now, that's minus the cone. The Flowerchild Project command module, the Flowerchild Project, yeah, Apollo command module has the cone point because the command module may or may not be capable of atmospheric reentry. The original concept is that there be a if the Flowerchild Project Apollo command module FCP Apollo was capable of atmospheric reentry, there would be a heat shield door on the down here. Let's go with a model cube. Name that heat shield door. There would be a okay. 4 foot. 4 foot. Move it to 50. Get all that. That is problematic. Okay, move it 0.5. So you'd have a door in the middle of the heat shield, which, you know, and the door itself would have there would be a seal, it would seal on the heat shield so that it would not burn up. I don't know if that's really realistic or not. Most likely it's not doable. So, but if the command module, if the Flowerchild Project Apollo command module structure was able to for atmospheric reentry, that would be the thing. It would serve as an abridged escape pod for the spacecraft series. That was the original concept. But that heat shield door structure may not be realistic at all. May not be doable at all. So, in which case, the this would be increased. And based on my numbers, based on my calculations, it's 15 feet from base to cone tip is about 15 feet. That's my guesstimation. Let's get out of here. Yes, we want to do frequent saves to prevent the glitches. Models from changing positions and whatnot. Like that. That. Delete. You lost the heat shield door too. Okay, let's try. Let's do something a little bit different. Actually, let's go that route. Okay. Let's do the edges. Okay. Oh, come on. Oh, this is going to be a pain in the rear. Okay. Edges are out of it. Okay. Faces. Let's see what this does. Unless okay, let's move. That's not gonna work. This is gonna move the entire thing. So let's go edges. Let's see if I can mark out edge. Okay. Let's go edges. Okay, that's not the edge I was want to hit, but that's going to be knocked out anyways. I got dead zones on my fingers, so I gotta be I gotta orientate my fingers certain ways for it to kick in. Oh. Fluctuates. There, now okay. And so that's that. Okay, so it's 9 feet. It's between 13 and 15 feet on the coin point. Okay, we're just going to leave it at that. Let's see here. Command module, remove it to 0. I'm going to take it to 100. We're going to rotate it. I think that's the right one. Okay, let's see here. We're going to move it X to 30. Oops, wrong one. Okay, which is why I wanted these color coded, so I know which one I'm doing. This is the first time where the color coding really matters. So the nozzle is going to be over here. So the spacecraft is, I believe the Apollo CSMLM is approximately 60 feet in length. That's the command module, the service module, and the lunar module attached to the command module during the lunar Earth lunar trip to transit, and that's with the landing gear either folded or in landing position. I'm thinking in landing position. The lunar module and the landing position is approximately 24 feet in length. The command module with 9 feet, so it's 9 plus 24 is 33. That means the service module is 27 feet in length. That includes the nozzle. There's a nozzle structure design. The Flower Child project replaces the J2 engine on the service module with a F1 STQ engine. Basically, it's an F1 engine, F1 size engine that burns cryogenic fuel. That has an 8-foot nozzle. So the it was just doing the dry mechanical replacements. Just take out the engine and then on the end replace the engine, the J2 engine on with the F1 engine. You can do that. There'll be structural designs and stuff, but the F1 STQ engine, it has different component design features and stuff than what the F1 kerosene engine has, because hydrogen fuel, liquid hydrogen, has design features that the kerosene engine does not have, because liquid hydrogen as a gaseous item is difficult to contain compared to kerosene. So there are different mechanics involved, structural designs and stuff involved in the plumbing and the components of the F1 STQ compared to the F1 engine. That's beyond my knowledge and expertise, but it's obvious, if you're paying attention to spacecraft technology, real-life spacecraft technologies. So, let's see here. Move it. So it's minus 30. Okay, let's, okay. Let's do a measure cube. Move it to 100. And then Apollo CSM LM measure cube. So you know not to destroy that. Let's move it 106. That's close enough. Command module, let's move it over 34. Oops. Negative 34. Negative 35. Okay, let's see here. Rename that. FCP Apollo. And the 1990s, in the 1990s, when I got the stuff from NASA, I was working on what I refer to as the FCP-STS Habitation Module Design, which was basically it would be the oh, come on. Habitation? Habitation. Okay, habitation module. Okay, so basically what I'm going to have to do that. Okay, and FCP-STS, there we go. There we go. That's what now what this module design is, let's center that. Get out of there. Oh, I don't need you. Okay, what I need is scale it. So the purpose of the FCP-STS Habitation Module Design and the 2004 presentation folder was to demonstrate how the Flowerchild Project Habitation Module Designs can change due to different mission parameters and stuff. The original concept habitation module design was to place the lunar module with a habitation module. So the Flower Child project did not have a means of doing lunar surface missions. If you want to do lunar surface missions, you would have to have a lunar module spacecraft design on top of the standard Flower Child project command module, habitation module, propulsion system module, service module layout. And so you'd have, but you see, the reason I was not concerned about lunar landings is because the Flower Child project is about researching orbit-to-orbit only spacecraft designs, technologies. The objective is to create an orbit-to-orbit only Earth-Mars interplanetary spacecraft design for civilian colonization of Mars, which would require a spacecraft that's comparable to Star Trek, Starship, Enterprise, Battlestar Galactica, Space Battleship Yamato, Imperial Star Destroyers, Star Wars Imperial Star Destroyers, Star Wars Imperial Star Cruisers, the Robotech SDF-1. Okay. And so the reason I use the Flower Child project, the Mars spacecraft designs that I refer to as the model, as the Flower Child project model, is because the Starblazer's Argo, which is Space Battleship model in Japanese anime, and the Japanese and there's anime whatever is based on the World War II Japanese the real life World War II Japanese battleship model. It's redesigned and stuff, but it's what they did with the original Space Battleship model was they took a 1970s afterburner nozzle, which was used on the F-15s and F-16s and Tomcats and on jets, aircraft at that time. They took that kind of design and stuck it on the stern of the battleship model. And then what they did is take that mass and added that length to the bow of the model to make it look more balanced. That's my opinion. And so there's some design modifications there, whatever. But basically that's what they did. That's the basic concept. And then there's design features that has to be done and stuff. Structural design, restructuring, then the revised. Then when they started doing the remakes of the Space Battleship model, the hulls got longer and longer. So yeah, okay. So this is the habitation module. 60 feet in length. This is the length that can be fit inside the STS space cargo bay. And then you got 15 feet in diameter. So while this volume is would be representative of the Apollo CSM LM spacecraft design, Let's rotate that. I think that's the right number. Yeah, that's the right number. Let's move it to 100. You see that, yeah, the Apollo CSM LM would fit into this habitation module design. But what the STS, the FCP-STS is the entire habitation, and then you have that's the habitation. Then you have the propulsion system, the service module, or well, the service module could be redesigned for different fuel capacities, different number of engine motors, mountings and stuff like that, and so and then different fuel capacities for the different engines. So now the original concept okay, you name that FCP Habitation module, habitate version 1, or actually, yeah, the version 1 is, okay, there are within the (2004) presentation folder, the flower child was not specified. I did not specify that flower child was a spacecraft series. I mentioned Type A, Type B, Type 1, and Type 2 formats for the flower child spacecraft design. The original habitation module design, version 1, I do that, is 24 feet and 31 feet. Now, within the presentation folder, the 2004 presentation, the habitation module designs were 24 feet in diameter, but I believe that, 22 feet in diameter, but that was because I was using 8.5/11 paper. Now using scale 1:1, while scale 1 equals 1 foot or something like that, and it came out to 22 feet could fit diameter of the thing, and so it ended up being 22 feet. And a couple months ago, I looked back. I took out the Apollo Moore 1970, April 1970 Apollo Moore, and it turned out the exterior diameter was 31 feet, which is the proper dimensions. But again, these variations are representative of this is what's possible, this is not possible. There, you know, from spacecraft design to spacecraft design. It's not, the Flowerchild project is not a spacecraft program like the Apollo program. Project, you know, it's not a Mercury program. It's not a Gemini program. It's not a Soyuz program. Okay, it's not a Skylab program. It's not what is that? Salyut program, the Russians space station program. Okay, it's not a, you know, it's not your typical. It's not your Elon Musk's Starship program. You're working on a specific design with a spacecraft design with specific measurements and stuff. No, it's the Flowerchild project is more like the Ford Motor Company making an SUV, making a four-door sedan, making a two-door sports car, making a station wagon. Back when I was a kid, they don't make station wagons. The SUVs replaced the station wagon. You know, making a box van and whatever. Okay, Ford also did the U-Haul truck designs. So that's what, you know. But within the Flowerchild, all these different designs, variations of the space vehicle designs, are orbit-to-orbit only spacecraft designs. So this is, okay, we're going to color code that. You need to do the habitation module, STS habitation module design. Let's see here. Material that. Color code that. Now, because of this new format, oops, no. Let's get all that. Delete that. I can't use the same codes. So, that's not the models I want to play with. This is the models I want to play with. Rotate it 90. Okay, then we move it to 100. I said 100. We're going to move it over. X. That's 24. 60, just go with 40. Wrong 40. Negative 40. Negative 20. Negative 10. Negative 15. 16. 17. Negative 18. I just go with 17 just for the And actually, what we can do FCP, copy that. Let's move it to 200. And then remove that. No, wrong one. $200. Get out of there. Okay. Copy that. And we'll move that to 200. Okay. Now, what this section does, what the original is, because it's you have, wait a minute. You got 8-foot sections. That's basically, there's no frame. You got paper thin line, It's 8-foot sections. Sheet metal separating the sections out, basically. What version 2 does, okay, so let's give you another one. FCP Habitation Module 2. What version 2 does is actually add frame structure to the spacecraft, to the habitation model structure design. So it is still 31 feet in diameter, but you have the interior frame, the frame structure is theoretically 1 foot thick. So therefore you have an interior space volume of 29 feet in diameter. And you have 8-foot deck space between, you still have the 8 feet deck space, the 3 different decks, but you have a 1 foot frame structure between each deck and on the outer walls. So you have 24 feet plus 1 foot out here, 1 foot there, that's 2 feet, 1 foot there, that's 3 feet, and 1 foot there, that's 4 feet. So 24 plus 4 is 28 feet. We're going to move that to 200. And we're going to move that -10, -12, oh yeah, -13, let's see here, -14, -15, where's it even at that? So that's the difference between the different habitation modules. That is representative of how the flower child habitation modules can fluctuate over time. The purpose of this is to basically use the STS space shuttle as the transorbital vehicle for Flower Child Project spacecraft modules, command modules, service modules, whatever, and put it in Earth's orbit, and then assemble the Flower Child spacecraft in Earth's orbit the way the STS was assembled. Now, the reason why I went with the replacing the lunar module with the habitation module with the landed form of the lunar module is because I don't know the sciences and technologies, research and exploration that NASA wants to get into, would be interested in, and I don't know the type of equipment that would be needed for the various experiments that they're going to be wanting to be doing. So I wanted to have a very large area, deck space for the scientific exploration on the mission deck. And yet the 24-foot structure of the lunar module gave excellent three deck area space: the mission deck, the common area deck, and the privacy deck. The mission deck is the mission of the scientific exploration, activities, research, whatever they want to do with the spacecraft. The common deck is where the astronauts eat and recreate and exercise. The privacy deck is where the astronauts sleep and bathe and spend, quarantine time, and medical bay, sickness quarantine. Each astronaut has their own private quarters. So they have space, they have their own personal recreational activities, positions that they bring for recreation and psychological balance. Let's see here. Now, as I said, the version 1. Come on. Let's move it. See, they're eating each other, and they're not. This version, okay, that's this one. Nope. No, that's not, wait a minute. That's this one. So, okay, remove it. Negative 34. Okay. This is what I refer to as eating. When the modules are not adjacent to each other, especially when they need to be adjacent to each other, I call that eating. I'm just doing that for this is my own terminology. So for reference. Okay. Now the service module is 27 feet. The J2, okay, I was at Johnson Space Center in Houston in 1978, 1979. During the Tour of Texas program. I was 5'5" at that time, 100 pounds. Let's see here. The J2 was about my height. So the J2 engine was based approximately 2 feet by 2 feet by 2. That's not the correct measurements, but it's in that range. And so the nozzle was approximately about 4 feet, I believe, in height. So it was approximately 6 inches, 6 feet overall. So 37 subtract 4 is 30 feet. 30 feet. Okay. New module. We're going to rename that FCP Child Project Apollo I don't know where these guys get their coding from. Service module. Now, there are different module design formats for the propulsion system. This is based on the 2004 presentation for the data, which is the original concept of the Flower Child Project, which is 1985-1986 concepts. Scale that 13, 37, that's 33. Color code that. Rotate it. 90. 90. Move it to 150. Move it to 160. I want to make sure we're not. Ooh, damn. 65. Okay. Now we need to X 10. Oh. That's cool. So and then you have wait a minute. BF1 engine nozzle. Make sure that. Color code that. Grade. I'm going to go down there. Rotate it. 90. 90. Move it. 150. $30. Oh, you didn't scale that yet. Come on. Rotate it. Then move it. That's good. Okay, you need to measure scale it 8.1 4 feet diameter. I don't know the actual measurements on that, but I'm assuming it's about 4 feet. Okay, then we're going to move it. Okay, we're going to go up 150. And then we're going to move it to 30. And then we're going to the engine, okay. Skillet. Okay, you got all that. By cylinder. Engine nozzle. Rotate it. I said 90, and I did 3 accidentally. Come on, get in there. We are going to move it. Let's move it to 0. We're going to move it up again. Make sure it's not eating. 160. Come on. No, wow. 155. It's eating it. Okay. So that's 31. Ooh, 30.5. Sometimes there's gaps in the decimal range. Come on. Okay, so this is what this is the original version revision of the Apollo CSM would look like for the Flower Child series. That's the original revision. On the external appearance, the basic redesign. Now, because the F1 engine is a huge monstrosity, and because the F1 engine burns through a lot of fuel, in a way that the J2 does not, you're going to need a bigger fuel. The source models are designed for the F1 will have to be changed and be enlarged. Now, to what extent, I don't know. I don't have the numbers. I don't have the mathematics. So now, but again, actually, version 2, -16.5. Come on, 0.5. Let's do that. 220. Yeah. You see there, that's oh, I mistyped. 15.5. No, come on. Yeah. Oh, there is some eating going on there. -16.4. Okay. We're going because of the lipping over here on the, we're just going to go at that. 100. Okay. Actually, this is, copy that, move it to 200. -20, no, 15, 14, okay. Get in there. Come on. Copy that, move it to 160, nope, 210, 205, we want to move it another 4 feet, 34.5. Move it to 200. 200. Okay, so actually this is the design theory. This is what it would look like with mechanics. So actually this is a more accurate representation of the difference between the Flower Child and the Apollo CSM-LM. Let's see here. Okay. Okay, and then the measure cube. Where's that measure cube? Just move it. And then copy that over to 100. Move it. Oh, come on. Minus 40. Oh, no, wrong. Positive 40. 5.5. Nope. 6. 46. No. Move it to 100. What? Where are you? There we go. And then we go with copy, move it to 105. Oh, wow. Nope. $69, $68, $67, $66, $66.5, $100, So these are just variations of what the Lunar Child could be possible for the Lunar Child series. So, yeah, the Flower Child project is not your standard spacecraft design program. It's a totally different kettle of fish. So, and like we said, this is a multi-motor engine spacecraft design. So, we're going to make the assumption let's just say this. Crapola. Well, I'm done. Okay. Bye-bye.